Hi there, my name is Grace Ann, and I'm going to go through my operations research midterm 3 problem 2. To start with a little bit of background, we're talking about Grant Hill Associates and their holdings in Malaysia that they're trying to get out as the market collapses. So as we start this problem, there's about $22,280,000 in U.S. currency within this market. And so to get a little bit more grasp on this problem, I drew some flow diagrams of our minimum cost flow. So to start, we have 3 different supply nodes. The one I'm going to talk about first is the yen. And so we have about $15 million worth of yen in holdings right now that we really want to get out and back to US dollars. So as you can see on the chart, there is a capacity that putting yen from euro or to any other currency, you can't exceed that limit. And so that limit is drawn in blue on the graph, and you'll see next with the rupiah, the same kind of idea with this capacity limit. For this, we have about $1.7 million of US in US equivalency that we're trying to get out and back to US dollars in the supply node. And then lastly, we have the ringgit, which is also a supply node. And so all of these supply nodes we're trying to get into US dollars for the lowest cost possible. And so to get a little bit better understanding of why we're doing that, each of these currencies does have a cost associated when you do go from one to another. And that is seen in the upper right-hand corner of this slide. You can see all the different costs going in between. Ideally, these would be on the graph, but as there are so many, it was a little bit more clear to put them in a graph. And so the graph to the left-hand side actually goes through, we can see that there's 3 supply nodes, there's 4 transshipment nodes, and then there's 1 demand node, which is US dollars. We're really trying to make the amount of money that gets into US currency the greatest it can be while minimizing the cost of the transactions. And so we can put this into a minimum cost problem. And as there are so many arcs and so many nodes, this is a little bit messy, as you can see, but essentially we're just taking the cost of each transaction and multiplying it by the arc, which would be a variable here. So you can see like the first one is 0.005, which is 5.5% of however much currency you're going from one to another, from the yen to the rupiah. And that continues on for each arc. And that is subject to these capacities that we were talking about earlier. So we want to make sure that everything coming out of the supply nodes ends up being 0. So we have no more yen, no more rupiah, and no more ringgit. And those are all going into the system and hopefully getting to US dollars. Similarly, because this is a minimum cost flow problem, these transshipment nodes need to have a grand sum of 0. So you can't have any nodes that are just stuck in euros or any currency stuck in euros. It needs to go somewhere to get to the USD. Yeah, and so this last constraint that I have here that I hope you can see is less than or equal to $22,280,000. That is actually the grand total of the system. So we're saying here that the last node, the US dollar node, needs to be less than or equal to the maximum amount of money in the system. Just to put some constraint on it, we know that money can't be created in the system as we are losing money as we do transactions from one currency to another. And so now I put this into IBM and I formulated a little model there. And so with all these constraints on the capacities, we find that Jake would have $21,600,000 to put into US bonds. That means he is losing $680,000 in those transaction fees, but he is getting his money back into US bonds. And so the next question here is, what would happen if there weren't transaction limits, if we didn't have those blue capacities on the arcs coming out of the supply nodes? So putting that into IBM again, we find that Jake would now have $22,193,620 to put into US bonds. Obviously more if we can go directly from supply nodes into US dollars. And it does, you can see here too, takes less transactions. There's less amounts of arcs needed. And so this does cost $86,380. And lastly, we start to consider what would happen if there was a 500% transaction increase on the cost of any transaction with Rupas. So that means that it would be 5 times the cost any ARC that was connected to the Rupa supply node. And so what happens here then is Jake would finally have, or he would end up having $22,173,460 to invest into US bonds. So other factors here, I think that Jake did a good job about understanding what's happening in the system and really trying to get the money out as quick as he can. But I think that he overlooks the nature of a market crashing. So with sensitivity analysis in mind, Jake forgot to ask the question of what if this Japanese collapse would affect other markets. And so part of that issue is if these transactions aren't happening on a millisecond basis, it could take more time to get money from yen to euro. And in that time, another market might react to this and might actually fall, maybe not to the same extent, but at least a little bit to affect this. So I think this does need to be a little bit more of a dynamic model rather than a linear model. But overall, with the information given, he did a really good job about trying to maximize the amount of money he was getting back to Grant Hill Associates. And so with that, thank you. And I hope you enjoyed this problem about currencies.